Hi everyone. Today we are going to add on to what you learned yesterday about the derivative or the slope of the tangent line. That's the things that we focused on yesterday. We're going to learn a new formula today and hopefully get a better understanding of why it works. First thing I want to do is just briefly show you this Desmos activity, which I'll put the link back up in a minute if you want to see it and look at it on your own. So what we have here, actually make this bigger, and you don't need to see this, is a cubic function that has two things drawn on it. It has a tangent line and it has a secant line. The tangent line is tangent right at this point here, and then this is the secant line, the dotted one that has 2 points. In the world of algebra, you were only ever able to find the slope of a secant line, meaning you could only ever find the slope between 2 points. So you'd find 2 points on a function and you'd connect them. Well, clearly connecting these 2 points here on my graph, what is this value? Negative 2.15, negative 1.9. Connecting this point with the purple one does not have anywhere close to the same slope as this tangent line over here. So what could happen is if you choose the wrong 2 points, you're not going to get a good secant line to match your tangent line. So that's part of the reason that limits came into play for this, is you're able to, so this is what happens. Okay, so you've got this point and you want this red point to get closer to this purple point. Let's put this purple point maybe on a whole number if I can. Okay, so I want the red point to get closer to the purple point. And as it gets closer, remember that's what limits do. So by taking the limit of something, you're pushing one thing closer to the other. So we're pushing the value of that red dot closer to the purple dot. And as it goes right on top of it, it becomes the same line. It actually becomes the tangent line right there. So you can see the farther away the 2 points are, the less likely their slopes are to match. And then as you approach having just the same point, you end up with the exact same slope. So the idea of the limit here is to say, let's make this distance between the two so small. I can even zoom in here so you can see it. It's like make the distance so small that it practically doesn't exist. And once you get it closer, it becomes the same line. So there's the link if you're curious about playing around with it there. So yesterday, you should have watched the video and learned about the instantaneous rate of change, which again is called the derivative, and you learned the formula that is on the left. The formula on the right is a little bit different and can sometimes be a little more complicated. It looks more complicated for sure, but it is sometimes way more beneficial depending on the situation that you have. So the one on the left, you use this method. So remember, it's called tangent line. It's called instantaneous rate of change. It's also called the derivative. Both of these are called the derivative. And then we have some notation that I'll write down below in a minute. Okay. We use the method on the left when you are trying to find the slope or find the derivative at 1 point. So maybe you're given like find the derivative at x equals 2, find the derivative at negative a half. That's when you would use this formula. It works really well when you're told to find it for 1 point. The one on the right, which I think even would have learned how to do the part without the limit last year. The one on the right you use when you are finding the slope or finding the derivative, finding an expression, let's say that, find an expression for the slope or the derivative. So basically, if you aren't given a point or aren't told a specific value, then you would use the formula on the right. Okay, so you've got left, you're given an exact number for x that you're trying to work with. One on the right, you want an expression or you aren't given an x to work with. Several different notations. The one that you'll see used the most is this notation here, and we say that is f prime. You'll also see it written in this format. This we would literally say dy dx. You read it just the way it looks, dy dx. If it's something that's written in terms of y, you could also write it as y prime. So that again would be read as y prime. And then depending on what other information you're given, sometimes it might just be d dx. So if you just have an expression and there's no y in the problem at all, then this is the one you would use. So when there's no y, and you just have an expression. All right, so we've got these notations, we've got these two formulas. Let's go ahead and look at our first example. So example 1 says, find an expression for the derivative of f of x equals x squared minus 1. And here's what's so nice about finding the expression. Once you find it, then you can use it to find any of the slopes that you want. So you can find as many slopes as you need. So I'm going to rewrite the formula here again, just in case you forgot it or didn't copy it down. So it's the limit as h goes to 0 of f of x plus h minus f of x over h. And so this means that you're substituting x plus h in for x in the first spot. So this will look like this for our problem. So this will be x plus h squared minus 1. So this red here is this red up here. Then it says, all right, f of x. So now I'm going to subtract f of x, which just means subtract the function. So that's x squared minus 1. And all of that is over h. I can't stress to you enough how important it is that you rewrite that limit every single time. You will get marked off if you don't write the limit down every single time. So there I went ahead and I squared it. And then here I am distributing the negative. If you do this correctly, anything that doesn't have an h in it will cancel. So the x squareds cancel and the 1 cancels, and I am left with 2xh plus h squared. So everything in the numerator and in the denominator has an h. And before I can take the limit, I have to get rid of the h in the denominator, because if I don't get rid of it, then I'm putting 0 down there, and that's not going to work. If I tried to do it right where it's at, 2hx plus h squared over h, there'd be 0, 0, 0, and I would have to do more steps, which is what I'm doing right now. I like to factor out an h. You don't have to, but I do like to do that so that I can see clearly that I am going to cancel out the h's. So now those h's go away, and now I can substitute 0 in for h. So I put 0 in here, and I just have 2x. This is the expression for the derivative. So we could say 2x equals f prime of x. Okay, well, that's great and all, but now I actually want to find the slope. And I believe the problem, let me scroll back up, wants the slope of the tangent line at 2, -1, and 3. So I'm literally going to do f prime of 2, f prime of -1, and f prime of 3. Substitute each of those in to my derivative here. So the slope of the tangent line at x equals 2 is 4. At x equals -1 is -2, and at x equals 3 is 6. Basically what this means, okay, so if I draw a quick sketch of my original function, let me go ahead and label that here. So here's my original function. It was f of x equals x squared. What we're saying is if I draw a tangent line at x equals 2 right here, the slope of that tangent line is 4. And if I draw a tangent line at -1, then the slope of that tangent line is -2. And my graph isn't big enough for you to see the 3 and the 6, but I hope you understand that as it goes off to the right, the graph gets steeper, which is why my slope would be a bigger number. Okay, so that's what this information is telling us. If I draw a line at that point, that's the slope of that line. Okay, it can get a little more complicated when you have more x's in the problem. So here's the first example here. So I want f prime of x, which I find that by writing the limit as h goes to 0 of, and I'm going to use different colors here again. So the f of x plus h part is first. Get a little more space. Okay, so I have 2 times x plus h squared plus x plus h. So that's the first part of the formula. Then the second part of the formula is when I just rewrite the function. So that would be 2x squared plus x, and then the whole thing is over h. So again, anywhere you see an x, you're putting x plus h, and then you're copying down the function. Don't forget to copy down the limit for every single step. And now we have to do some careful algebra. So this is 2 times x squared plus 2hx plus h squared plus x plus h minus 2x squared minus x. So I also distributed that negative there. You'd think I'd be better at drawing a straight line. All right, this becomes 2x squared plus 4hx plus 2h squared plus x plus h minus 2x squared minus x. Remember what I told you before, anything that doesn't have an h in it should cancel out. So this 2x squared cancels with this negative 2x squared. Negative x, positive x goes away, and I'm left with everything in the numerator that has an h that I just have to either factor or cancel, whatever you like. So some of you are good at the understanding or remembering of how this works when you cancel, and some of you forget. So that's one of the reasons I like to factor. So when I factor out an h from this spot right here, I'm left with a 1. And like I said, a lot of people forget that. So that's why I like to sometimes factor, but you don't have to. Those h's go away. I can now put a 0 in for h, and I end up with an answer of 4x plus 1. This is the derivative, the expression for the derivative. Okay. All right, so now this one is one step farther. We want to find the equation of the tangent line to the curve. So I'm going to actually be writing a line, which means I need a point. And I already know that the point is supposed to start at x equals 1. And so I'm going to substitute 1 into this function here to figure out what the y value is. So I get 1 plus 1 plus 3 is 5. So that's the point I'm going to use. I'll use point slope form in a minute. But now I need to find the slope. And this is where you have to make a decision on the best choice, right? So remember, we started off the lesson by saying if you're finding the slope at a specific point, it's better to use that f of x minus f of a formula. A would be 1 in this case. So I'll write it out so that you can see what I'm talking about. So it's going to be the limit as x goes to 1, and it'll be f of x minus f of 1 over x minus 1. And I'm just copying my function down, x cubed plus x plus 3 minus, and then I'm substituting in what I get when I put 1 into the function. Well, I actually already did that. I did that up here in orange. When I put 1 in, I got 5. So I'm literally writing down 5 in that spot. And then x minus 1 in the denominator. Okay, I'm going to simplify, but it's still not going to get super nice. We're still going to have to do something else. I'll probably do something else off to the side here. So I have x cubed plus x minus 2 over x minus 1. And if we substitute 1 into the numerator and the denominator, we would see that we would get 2 minus 2 is 0 over 1 minus 1 is 0. I get an indeterminate form, which means I should be able to do something else to figure out what the limit actually is. It has a limit. We just have to go through a different process. That numerator isn't factorable, so your best choice would be to either do long division or synthetic division. Since I'm dividing by a linear term, so x minus 1 is linear, I'm going to use synthetic division. So I use the opposite of that minus 1 out in my little box, copy down the coefficients of the terms in the numerator. Notice there's no x squared, so I put a 0 there. And now I can just do my synthetic division. 1 times 1 is 1, add them up, multiply, add them up, multiply, add them up. Yay, we get 0 as a remainder, which means this is the limit as x goes to 1 of just x squared plus x plus 2. And now you can put 1 in and you get 4. So your limit, which is your derivative, which is your slope, is 4. I now have a slope and a point. So remember the point was 1 comma 5. And I'm just going to use point slope form of a line. So I'm going to do y minus 5 equals 4 times x minus 1. And just leave it. Part of the reason we like you to leave it here is that sometimes you'll be asked to find then the equation of the perpendicular, but through the same point. Well, if I asked you for the perpendicular, then, which by the way is also called normal, then you would do the opposite reciprocal of the slope, but the point doesn't change. So you don't have to do all this extra work. You just flip and switch to get to the equation of the line, the perpendicular line. All right, so I have 3 practice problems here for you. I'm not going to talk as I do them. I'm just going to write them. And what I would like you to do then is to watch and think. And then if you have questions, you can ask in class or you can put it in the question and answer document. But I just want you to watch. Maybe you don't even need to see these. So maybe you'll be fine and you won't even need them. Okay, so this one is a little tricky. And initially, my gut is telling me that I should substitute x plus h in for x the way that's written. But I think our better choice actually will be to distribute out this problem. It'll be a little bit easier to work with if we distribute. So we create this as x squared minus 6x plus 9. Otherwise, you're trying to distribute the x plus h in the squared part, and it just gets way more complicated. So I do limit as h goes to 0. I said I wasn't going to talk, didn't I? All right, that's it for me. If you have any questions, let us know.